Good afternoon. We're Precious Cargo Solutions, a small startup engineering company based in College Station, Texas. And this is our preliminary design review. In it, we hope to share with you the first steps in the design of our product, Belt Alert. Precious Cargo Solutions is comprised of
Don Kwong, the lead software engineer.
Jerome Monroe, the testing engineer.
And Eric Ingham, the project manager and hardware engineer.
Currently, there are no technologies available for the protection of rear passengers in a passenger vehicle. We all know the sound that you get when you're in the front seat and you're not buckled in. You get that beeping sound. It might be annoying, but that sound saves lives. There's nothing for the back seat right now. With Belt Alert, we hope to change that. Belt Alert is a seatbelt sensing device. When, in the event of a car crash, rear passengers become projectiles, and we hope, in all likelihood, to reduce the likelihood of fatalities for not only rear passengers, but front seat passengers as well.
I will go over the concept of operation. There's 4 major parts for the concept of operation. The first, Belt Alert must be used in a vehicle. Second, Belt Alert will sense if there's any rear passenger and detects if they're buckled up or not. Third, Belt Alert will alert the drivers, produce a sound alert to the driver if the passenger is unbuckled. Fourth, if the driver left the car and the passenger is still buckled up in the vehicle, it will warn the driver. For functional requirements, the Belt Alert must be cheap enough to be sold in large chain stores. It must detect the passenger in the seat and in the rear seat and sense if the seatbelt is buckled or not. The Belt Alert will alert the drivers if the passenger seat is unbuckled. It must have a self-contained power source, and if it's low on power, it will warn the user. Belt Alert will be made for one particular manufacturer. However, it will be expandable for more manufacturers. It must be easy to install for non-technology users, and it must not interfere with the seatbelt functionality, and also it must be resistant to the climate changes.
To detect if someone's in the seat, we're going to use a pressure pad sensor switch, and to detect if the seatbelt is buckled, we'll use a proximity sensor switch. These will be connected to a sensor relay. This will be wirelessly connected to our monitor, which will have a visual and auditory alert, as well as a user interface to override alarms. Say if you put groceries in your back seat and it sets off the alarm, you don't really care. This will also be wirelessly connected to a cell phone. The cell phone is not part of our project. We're not designing it. We're just going to, at most, design an Android app to put on the phone.
Our performance specifications. Belt Alert should have a wireless range that can span the length of a school bus. Right now, our scope is a passenger vehicle. However, with the trend towards seatbelts in school buses, we would like our product to be expandable to reach those needs. The sensor module should have a battery life of at least 3 months, and since we are using or chose to use Bluetooth, the low power states in there should allow us to achieve the power consumption that we want. The monitor module should be able to accept or handle 12 volts of power. We'll be connecting that to the cigarette lighter. So the power output from the cigarette lighter is about 12 volts. So the monitor should be able to handle that much. The sensor module should take input from 3 different seats The average back seat has 3 seats, so we want to be able to encompass the whole back seat with one module. The magnetic sensor that we'll be using should be strong enough that it will do accurate sensing, however, not strong enough that it will demagnetize credit cards or IDs. One of the most important parts of belt alert is that it should be cheap. It should be cheap enough for any single mother or father to go into a large chain store, pick up a belt alert, and protect their child. We'll also be using a pressure plate. Our pressure plate should be able to have a minimum reading of 10 pounds. The average premature baby's weight is 5 pounds. If you add the weight of a car seat to that, then we should be able to encompass every size child that a belt alert should be able to protect.
This is our functional block diagram. We do not currently have specifications for all the components. We plan on having 3 sets of sensors maximum. They will be connected to the GIO pins of the processor. Since there's 3 sets, that's 6, so we'll be using at least 6 GIO pins plus a ground to operate these switches. The power will be provided by a battery for the sensor relay. It will be put through a power regulator to divide it down into the proper voltages for our processor and other components. And it will also have a battery monitoring system to detect when the battery is getting low. This will be plugged into the ADC pin of the processor, so the processor can relay that information to the wireless module via UART, then further on to the monitoring system. Our monitoring system will have a visual, audio, and user interfaces. These will be connected via the GIO pins. At this point, we haven't decided on the visual if it's going to be just LEDs or if it's going to be an LCD screen. So right now we're assuming LEDs and we'll go GIO pins. The power for this will be coming in through a 12 volt off the car and a backup battery for when the car is turned off, if the 12 volts turns off with the car. It will go through a power regulation system to filter out any noise from the car. And the battery will also have a battery monitoring system connected to the ADC of the processor so that it can detect when the battery is getting low. And this processor will receive information from up to several sensor relays through a wireless module, communicating with that wireless module through UART. The switch we're looking at for the proximity switch is a Hall effect switch. It measures the magnetic field. The one we're looking at currently has a supply voltage of 2.5 to 5.5 volts. That will cover the supply voltages for most processors of 3.3 or 5.5 volts. So we don't have to create another voltage in our system. The operating temperatures, this in Fahrenheit is -40 to 185 degrees Fahrenheit. That should cover the temperatures of a car when anybody should be inside of it. Cars reach quickly in an hour up to 150 degrees. If you're still in that car, you're in trouble. This covers the magnetic characteristics of the switch we're looking at currently. It will activate at either between 35 and 50 Gauss, regardless of polarity. That's what the negatives are here. And it will release between 10 and 25 Gauss, regardless of polarity. And the range in between them, the 25 to 35, is 10 Gauss. At this point, the switch will stay in the state it was before entering that range.
For communication, we chose to use Bluetooth because it is a small package and inexpensive with a short range of 10 meters. It uses a 2.4 gigahertz unlicensed radio band with a top speed of 723.2 kilobits per second, and it operates in a noisy radio frequency environment. Bluetooth uses a point-to-point or a point-to-multipoint topology. A Bluetooth package consists of 3 entities: the access code, the header, and the payload. The access code has a fixed number of bits. of 72 and header with a 54-bit. It goes through 5 logical channels: the LC, LM, UA, UI, and US. The LC, LM control are used in the link, the logic, the link level, and the UA, UI, US is used to be asynchronous, to transfer asynchronous user information. And for Bluetooth devices to communicate with each other, each device must have an internal clock, and that internal clock determines the timing and the hopping. And each hop happens at 312.5 microseconds. It uses a 28-bit counter, and it is 3.2 kilohertz clock rate. In this phase of the design project, these are the deliverable dates for these are the deliverable dates, and
Okay. This is our technical merit. We have a challenge to produce a cheap system that can monitor a occupant in the seat and if the seatbelt is buckled to be integrated with current systems. We chose one. And we're integrating this with a car seatbelt system and a phone, so we chose point 2. Requirement for system testing: we will have to test it and make sure that this can detect the seatbelts being buckled and the weight of small children, as well as communicate with Bluetooth phone. So we chose point 2. The requirement for theoretical analysis: we're going to set up a simulation to test our switches to ensure that they work and get a better characterization of them. Hardware design: we will be designing at least 2 boards, possibly 3, depending on how we connect the Hall effect switch to the sensor relay. We will be designing firmware for 2 boards and an Android app for a phone. Those 2 boards will require enclosures that are water resistant to protect the circuitry from spills of small children, and it'll be able to handle the heat of inside a car. Documentation other than the project: we plan on competing in the TI Innovation Contest, so we'll have to prepare the documentation for that. For the last 2, we haven't decided on what intellectual property protection we're going to use, if any, so we chose 0 at this time, and we don't know what requirements were required by our sponsor after capstone, so we chose 0. Questions?
Can you go back to your tech merit slide?
Okay.
You said you're going to test your sensors for your simulation.
We're going to simulate the system to test the sensors.
How do you plan on doing that?
Building the board in the lab view and hooking the sensors up to it to make sure that they're meeting what we need.
So you're gonna make sure that it works. So you're gonna make sure it meets your functional requirements.
Yes.
That's testing. That's
Okay.
hardware design development and testing.
Okay.
Just a general question on this. It seems like you didn't understand Dr. Morgan's instructions. This was supposed to be all the technical merit or none of the technical merit. So for instance, on number 4, you either had a .2 that you're claiming or a 0.
Okay.
So you need to go and revise that before you present it to Dr. Morgan, because he probably won't like the way you interpreted his instructions. Can you go back to your deliverables? Y'all read through that so fast I couldn't even look at it.
Hard to look at it.
Hard to look at anyway. The color scheme is terrible.
Don, can you describe what we're looking at right here?
At stage 1, we'll do the functional block diagram, which was like last. And at stage 2, we'll do like a software function description and
So all of your deliverables are going to be run sequentially and nothing in parallel?
Well, right now, it's preliminary, as we've stated. It's not bad to have it sequential, seeing as we want some things done before the others. You can do things concurrently, but right now we have it sequential. I mean, if we do something early, we finish something early, we can start on something else. It's just a skeleton.
It's just the way that it looks right now. It looks like it's going to take you 2 days to do your Alpha PCB lab.
Good luck.
So this is not a deliverables timeline, this is a Gantt chart. You're showing tasks and time, right? What's the requirement for deliverables
Deliverable is
timeline?
something that you can turn in. I feel like
And when do you turn it in?
when
Yeah, what?
The due date.
And so that's not what you're showing me. You've got this fuzzy set of dates. You're supposed to be showing things that are due on specific dates.
right? So that end date is the date that it will be due. The other dates are extra information for the timing, the duration of the deliverable.
It's actually just making the slide look a whole lot more crowded than it needs to be.
It is, but it also adds extra information.
That's not enough information.
It's not what you were asked for.
Right, right.
Okay.
Can you go back to your functional requirements?
First one, second.
I'm just trying to see if anywhere in the functional requirements you have anything about groceries in a C. And if you don't have it, then why do you have it in your block diagram? Now, don't see it there, so go back one more.
Well, it's to detect a passenger in the seat. If it's not a passenger, we don't want to detect it.
But you said if somebody puts groceries in the back of the seat, you have a detection, an override method, right? Go back to your functional block diagram.
False positive.
One more. No,
Another diagram.
another one diagram. There you go, that's it. Keep going. Almost there. Almost there. Right there. That little blue lock mechanism right there. Yeah, that's part of your conceptual block diagram, but you didn't explain it at all in your functional requirements. Is it required or not?
Well, we don't want it alarming when
Correct. So you need to put that into your functional requirements, don't you? One of the problems we've seen in pretty much every project we do in cars are very, very noisy environments. When you've got an idea up there that you're going to filter out, voltage regulate the car's noise, I would put a simple guess that you're gonna have real challenge with that. Because the noise is not only flowing on the power line, it's also on the ground. So how do you filter ground? And you're gonna find a real challenge there. And when you're interested, we'll share with you our solutions, but that's gonna be a challenge. Dr. Ford, you got any questions?
Oh, yeah. Okay, so you quote a price of $50 a seat.
Correct.
So to monitor just one back seat, 3 seats, you're gonna charge the user $150 for this system?
That's
No. The $50 would be the initial setup. You will be able to buy the sensors right here separately. They plug in and add them to the sensor relay.
I interpret $50 a seat is $50 a seat, which is what your thing said, is that right?
I think it was an initial setup.
I didn't see that, I saw $50/seat, I think. So what is the system gonna cost for one car with three passengers?
Really
Ballpark?
depends on what our sensors end up costing, but we're shooting for $60, $70 to cover an entire 3-person seat.
Huh.
So is that your manufacturing cost, or is that the cost you're gonna sell to the customer?
Cost to sell to the customer.
Which means you need at least the factor 5 to make it a profitable venture. So you're gonna have to make this thing for $10 to $12. Think you can pull that off?
The sensor pad is gonna be our biggest concern there. Right now, I've only found one for the cheapest, $14.
$14 for just the sensor.
Yeah.
Ow.
This one, 34 cents for the
So
Hall
what
effects
can you
switch.
do with just that?
So explain to me how you're gonna use this Hall effect sensor. I don't know if you're gonna draw a picture for me on the board. I'm just trying to understand how this Hall effect sensor is gonna determine whether the seatbelt is buckled.
It's gonna be set up like a proximity switch on a window alarm.
So
So you have a
point to-
magnet is gonna be attached to this.
Yeah.
The Hall effects switch is gonna be attached to the back of this.
Okay.
Plug this in, it'll sense the magnet. And when you take it away, the magnetic field will drop below the cutoff.
Does that mean I need a new seatbelt?
No. These will attach to the back of it, either through epoxy or have it clip on without messing up the, you can't drill into these things because you be affecting the safety factor. The magnet will stick to the metal plate right up against the plastic.
If it's in a car or it could be a school bus or whatever, would you think it would be inconvenient to have to change batteries? Would you want to wire it in permanently?
The current request from the customer is not to have it wired in so that someone who has no technical background can install it.
Would that be more or less complex than installing like a car stereo or something?
We discussed that and he said he did not want any wires run, just simply set it up, plug it in.
Plan on having any kind of power down feature?
Yes, sir.
Was that one of your functional requirements that I missed?
No, sir, it was not included.
Was not included. You'd add that.
Estimates on battery life for the sensor unit.
We're shooting for 3 months. We haven't specified the battery, so that means we can change out the batteries from, say, a 9-volt battery to 2 C cells, D cells, or higher.
Do you have a form factor that you have to fit in?
Not really. We're shooting for the size of a eraser for the sensor relay, and it will stick to either the back or the front of the seat so the adults can reach it.
Did you guys do any actual testing on the holodeck?
No, we have not. Those are strictly off of the spec sheets.
Well, you better think about that because the buckle is ferrous probably, and it's gonna impact the magnetic field. I don't know what effect that'll have on the sensor, but it's possible that it's gonna route that flux through the buckle. The sensor's not even gonna see it. So you need to do some experimenting before you come up with that technology. Another question, you're suggesting that this thing is expandable for a school bus, yet you're specifying Bluetooth. Are you sure Bluetooth's gonna be able to accommodate a school bus?
We're also looking at Z-Wave.
So but you didn't say that.
We haven't decided on what we're using.
Okay.
Bluetooth is strictly for the phone.
I think you need to, but you need to think about that, because if you're gonna use Bluetooth inside of a school bus and detect all the seats all the way to the back, you know, I'm not convinced that you can do it.
We're also looking at Zigbee and Z-Wave, and the
Okay.
module I've been looking at covers all 3.
Well, these are decisions that need to be made earlier rather than later. The next thing is, you're gonna accommodate 3 modules with a sensor box,
Yes, sir.
three seats with a sensor box. I don't know why, but somehow that bothered me. Most families are gonna have a 7-passenger van, which means you wanna detect at least 5 seats. And I don't wanna pay for 2 sensor boxes for that. I'm just talking as your customer now. And if you're on a school bus, if you can do 3, why not do 4 so that you can accommodate 2 seats in that bus? Because you're gonna have 2 people in each seat. Is that right?
Yes, sir.
So I would think that you want to at least do 4 seats, and it seems to me to be better if you could do 5 with 1 sensor box.
The reason we chose 3 is because we're doing per bench and running the wires between the 2 benches.
I don't think that's that big of a deal. Maybe you can't do it, but it's not that big of a deal, but I just don't see any reason to have a sensor box per bench seat.
And the $50 would include the monitor and sensor box.
I understand.
The monitor is going to be expensive.
And I'm not sure what I'd pay for this. As a grandparent, I don't care about my grandkids. As a parent, though, I might. I'm kidding. I don't have grandkids. I probably would like them to.
All right, go back to your performance specs. General comment? Yeah, no, you pass right by. Performance specs.
Performance is beyond.
Right. There we go. Keep going. There you go. I was under the impression that Dr. Morgan calls that performance requirements. Am I missing what Dr. Morgan calls this versus what you call it? All on here, it says performance. Requirements, REQ. May want to get that right before you go to the first tab.
Then, so 1, 2, 3, 4, fifth bullet down. Magnetic sensor should have a magnetic field. That's not quantitative. We're correct. That doesn't belong to performance specs as a functional requirement. You need to dictate what the range of that magnetic sensor should be for performance specs.
Is there a reason that y'all don't just use contact switches or something instead of all of their sensors?
Hall fixes are going to seal against water, and little kids spill a lot of stuff, so we don't want to have to worry about the contacts getting dirty. We're also looking at reed switch. You would have to researching Hall effect sensors, replace reed switches in pretty much every application.
All right, so you have these pressure sensors and the seatbelt sensors, right?
Yes.
Can you tell what seat is being occupied, or is it just sending there's
It will
somebody
send
in the
which
back
seat-
seat to your
It will
monitor?
send which seat is being occupied.
So there will be a pressure sensor on each seat.
Yes, a simple pad, pressure switch.
Like underneath in the seat or on top of
It's
it?
going to be on top of the seat, so you don't have to get into the seat to install it.
It's the same thing that's in the front seats right now.
Well, those are in the seat.
Right.
But just out after running.
Have 3 more minutes for questions.
You also said you're gonna have a manual disable for a seat, so that it won't sense the seat.
Yes.
Is that the way it's gonna work? And so if you disable it, is it your responsibility to re-enable it?
No, it'll automatically re-enable, turn the car off and back on.
Just leave the car running.
I don't know why, that just inherently doesn't seem safe.
Alright, so what if someone gets in the vehicle and you don't cycle the power on the car on, you had already deactivated the sensor?
Pick up your kid at school.
Well, it'll be sensing that the person is sitting in that seat, so we can have the code.
You've already turned it off.
No, we've got groceries in
We
that
just
seat.
disabled them, we just turned off the monitor. That
So,
way,
let me
it'll
play
still
a
be sensing
scenario.
as they're playing.
Let me play a scenario, okay? You want to pick up your kids, you went grocery shopping before you do. Kids are always going to get in on the left-hand side of the car. You realize that, oops, I've got all my groceries in the seat that the kid's going to get into. You disabled it because you didn't want to hear it all go off. You move your groceries over so the kid can get in. You've never turned off the car when you pick up your kid. You've got a case where the kid can get in the car and you don't have any clue if he's booked. Right? There's an inherent liability that goes along with any project that is supposed to increase safety. If you fail to increase safety or your system fails to notify, there's an inherent liability on you. Okay, so you need to look through every use scenario to make sure there's no scenario where your system is defeated. That one would defeat it. I agree with Dr. Porter.
Go to Bluetooth slot, please. Bluetooth communication slot. Yeah, that's good. So, is it going to have to pair with each individual sensor? What's going to happen?
The monitor will pair with the individual sensors. We haven't decided if that's going to be Bluetooth or not. Okay. The monitor will pair with the phone to alert the driver when they leave the car or something.
You guys look at what Bluetooth profile you use for this application?
Sorry, what was that?
With that, bluetooth protocols, which one are you gonna use?
No.
Not yet.
I think we're pretty much done on questions. I think we've given them enough stuff to think about. We're looking forward to seeing how the next presentation